Thanks, everybody. Really excited to be here. We're going to talk about microservices. Who here has worked with microservices? Almost everybody. Who has at least heard the word before? Okay, that looks like that got everybody. Awesome. First of all, that's no moon. That's a Venn diagram. And microservices is kind of a big universe, and we're talking about just a little piece of it today. The UI implementation, I'm sorry, the UI implications of microservices. And so it might feel kind of like a fire hose in the beginning, just too much stuff all at once, or maybe there's some context that's missing. My apologies, we'll try to fix that. Who am I? Like Adam said, my name is Ethan. I live in the Western United States. And in the spirit of dirty confessions, I actually make my living programming in Node.js and not Ruby. But I got started in web development using a popular Ruby framework for making web applications that I'm not going to name because this is a Ruby conference. So yeah, that was good. Anyway, I'm also writing a book for the Pragmatic Bookshelf about microservices. And hey, if you want to talk to me about that, I'd love to talk about it. So that's me. So I just want to say this is not really an answers talk per se. There's a French philosopher named Claude Levi-Strauss, and he said that the scientist is not a person who gives the right answers. The scientist is one who asks the right questions. And so some talks you're going to leave with all the knowledge you need to go sit down and start coding right away. Maybe it's teaching you a new library, new framework or something. Unfortunately, that's not what this talk is doing. It's about questions and ideas and how you can reason about the systems that you're building. Because I think being able to ask the right questions is a lot more valuable than knowing what lines of code to sling. So, what do I mean by microservices? There are as many definitions of that word as there are cheeses in France, I think. And in the spirit of all being on the same page or having a ubiquitous language, if domain-driven design is your thing, what do I mean by them? Well, let's start with what a monolith is. A monolith is not a deployment strategy. It's not a way of putting all of your code into one repository. A monolith is a data model. What do I mean by that? So I mentioned I started in web development with a Ruby library for making web applications. And it pointed me towards a certain architecture. And a big part of that was the users table. Who here has ever worked on a project that involves users? Yeah, a few hands go up at that one, right? So this table is not unlike the ones that I saw in those days. And it felt awesome at first. It was amazing. 15 minutes from zero to blog. That's incredible. But it became difficult over time. There was this wall of productivity that I'd run into time and again, and not just on projects that I started. So it might have just been me, but it was every project based on this framework that I worked on. Over time, if you look at this graph here and you kind of squint at it enough and maybe tilt your head a little bit, you start to see, do these pieces of data really belong together? Are these pieces of data that are talking about the same thing really? Because when I look at this, I see at least 4 different domains on there. For example, an email and a password hash, those are really useful if what you're trying to do is identify a user, right? I mean, that's how people log in often. But what do the email and password hash have to do with tracking which features the user has used in a system? Those data are not at all related. The only thing they have in common is that they share a user ID, right? That's the monolith right there. When you try to cram all these very different domains into this one representation. So if you take a monolithic data model and build an application on top of it, you have a monolithic application. Here's an example of one. I've called out a user's domain, a product's domain. There is a database in the middle, and the greenish box means this is all running in one program. When 2 different things are running in the same program and they talk to each other, what is that called? What mechanism do you use to have one piece of code call another? What was that? In the same process, though. It's the same program. Method calls, yeah, function calls, exactly, right? And so when you hit that productivity wall where it's hard to keep doing stuff, you go to the blogosphere for help. We all love the blogosphere. And it gives you great advice, such as just extract microservices. So now I've pulled out my user's service and put it in its own server, its own process. It has its own database even. Surely I have services, right? But, what are those lines now that they're all on different services? I'm sorry, different servers. HTTP, exactly. But everything else looks exactly the same. My access patterns are all the same. All that's different now is it's on different servers, and all else being equal, who would rather deal with HTTP calls than function calls? Right? Bigger ops concerns, a whole lot more that can go wrong. So that leads to great statements like this one from Aaron Patterson. Smart guy, done a lot for the Ruby community. I think it's hilarious. Microservices are great for turning method calls into distributed computing problems. Yeah, only that's not microservices. So say it with me. Let's get audience participation here. Distributed plus monolith equals, drum roll, distributed monolith. If you've worked with microservices and this is what you worked with, you probably had a really bad time with it. A horrible time. My first introduction to service architecture was one of these stinkers, and I hated it, and I actually ended up leaving that company because I had tried for months to just say, let's just combine it all back together because it was so difficult to work on. But it's not services. So if you had a bad time with this, you didn't have a bad time with services, and that's really good news because there's a better way to do stuff. So what then do I mean by services? There's a lot of things to go into what makes something a service, but the biggest is autonomy. What do I mean by autonomy? Well, no one asks a service for anything. Services don't have GET APIs. They don't represent things. We have pieces in architecture that we get information from. We call them databases. And the process of asking them is called a query. And if you take a database and put it behind HTTP, you still just have a database. In fact, some databases ship with the ability to respond to HTTP right out of the box, so they're still just databases. Second, a service doesn't ask anyone for anything else. For example, if I have to ask you for something to do my job, you're now a dependency of mine, and I'm no longer autonomous because depending is the exact opposite of autonomy. And a really nice characteristic that comes out of this is that a service is actually completely oblivious to the existence of anything else in the system. And those other things are also oblivious to the existence of the service. So a service can go down and no one else goes down. Sure, your system's not going to do as much as it used to, but at least it won't be broken. How do they communicate then? That's through asynchronous messages, two flavors, events and commands. Events you can just represent them as JSON objects, but they'll have a type such as pen dropped. This is an exciting service that drops pens and picks them back up. But you as the system designer, you come up with those types. They're just strings. There are data payloads for them. That is in the past tense, and that's an important point because events are things that have happened. You can't argue with them. They just are. If you don't like the state of something in an event, you can write a command. So here's an example, drop pen. If I were holding a pen and you wanted that on the ground, you would send a drop pen command, and I may or may not accept it. Notice that's in the imperative mood. It's a command. I want you to do this. And commands can be invalid. They can be rejected. They can also be accepted. That's how they communicate. And what's really fun about this, if you're familiar with the concept of event sourcing, is that those events literally become the state of the system. So in the traditional MVC CRUD world, you might just store something like that table. So pen number 1 is currently in the picked up state. But what actually happened was first it was dropped and then it was picked up. So if you build a system like this, what are the major components to that system? Well, first of all, you have services. They are represented by lightning bolts because they are action-packed. They do stuff. If you've ever been hit by lightning, you know what I'm talking about. I really hope you haven't been, though, because that probably isn't very much fun. There is what I call an application layer. That doesn't mean that there is only one application, but this is where your projects based on that Ruby web framework would live. If you're in the Node.js world, this is your Express server, your Happy server. In the Python world, this is your Django server. And the application receives requests from happy users because we are professionals and our users love us. But the application will then write commands, sometimes events, to a transport mechanism called a message store. And services will observe those commands, write new ones, write new events in response to them. Then you have what are called read models, materialized views, sometimes called or just data views. And the reason you have that is because the lists of events in here aren't so useful for rendering a user interface. Unless you're rendering an interface for an auditor, they would love that kind of a thing. But most people aren't auditors, so we want different shapes for the data. And then there are what I call aggregators that take the events, the linear lists of events, shape them into things that make more sense for what you want to show to a user. And none of this implies that we're talking about a distributed system, because services are not the same thing as a distributed system. You can distribute, there are reasons to do it, but they really have nothing to do with each other. So what's a message store? Well, a message store is a database that's optimized for storing and retrieving events. You might have heard of the Event Store project, and you probably can't read it though. That's from Greg Young. He talks a lot about microservices and event sourcing. There's the Event Tide project. Nathan, who spoke here last year, is one of the co-maintainers of that, along with a guy named Scott Bell, where they have a Postgres backed version of a message store. And of course, there's the Rails event store that Andre and the folks at Arkansas maintain. So those are just examples of message stores. And that's the Firehose introduction to the world that we're talking about. So hopefully that made sense. If not, we'll be around for the next couple of days, obviously. Let's talk, because I love this stuff. So what I didn't mention was that these messages that are getting published, it's in a pub/sub style. So if I'm writing a message, I don't know who's consuming it. If I'm reacting to one, I don't know who sent it. And this all happens asynchronously. So that creates some potentially weird situations when I'm trying to give a user interface. A user does something, they want a response. How do I give them one when the information is not yet available? That's what we're going to get into with the rest of this. So first thing I want to say, though, who here has ever worked with 3D graphics or a game engine like Unity or something? Few people. Who's ever played a video game? Okay, more hands. So you see these objects in your 3D video game, and the way that they get created is someone defines the geometry of that object, in this case, a zebra. And there's what's called a texture map made, which links points on the zebra to points on a 2D texture that an artist would generate. I cannot wrap that around that in my mind, but whatever the case may be, there are people who can, and then using the texture map and the texture images, you end up with the textured zebra, okay? Here is a really disturbing picture that could be a texture map for a human head, okay? What would happen if you took the texture for the human head and tried to map it to the geometry for a zebra? You would get a monstrosity. That's what you'd get. But the point of this, so if you're in web development, there's a really good chance you came to it from the MVC CRUD style of architecture. Think of that as the zebra, smelly, can't be tamed. And then the texture, those are the ideas of the MVC CRUD architecture. The model here is your mental model. And then you get introduced to some new ideas, service architecture. if you try to take those ideas from service architecture and map them to the same thinking of the MVC CRUD monolith, you're going to have a really bad time. And it's not going to make any sense. You're going to say, this is stupid, and you're going to write articles like the Majestic Monolith. So, said another way, if you've started building a microservices system and you got to this point where you just have an HTTP form over a row in a database, and that's when you start thinking about what are the implications of the eventually consistent pub/sub model, you're going to have a bad time. This is too far down the process to start thinking about it. You'll need to step back and re-examine what you're doing. And the way to do that is set aside all the technology, right? We're good with technology, set it aside. Figure out what experience is it that you want to deliver to your users. Once you've got a firm idea of that, and of course that's revealed by talking with your business team, your UX experts, then start figuring out the technology, because the technology, that's the easy part. Knowing what you're supposed to show your users, that's the hard part. So let's get into some specific use cases and things that might help. And the first one is sometimes nothing is enough. Like, don't even care about the asynchronous nature of it. There are cases where that's valid. I'm thinking like analytics stuff, or if you really hate your users, you can also ignore it, but don't hate your users, they're nice to you. But suppose that we have a website where you're tracking video views, like a YouTube like a YouTube, that's a good example. And you want to know how many times a video has been viewed. Do your users really need that in real time? Like if you sit and watch a video on YouTube and you get to the end of it, do you expect the view counter to go up by 1 right in that moment? I don't. In fact, I saw this video once where they get to it's 137 or something, and then it won't go up anymore because that's the point at which they start investigating, are these actual legitimate video views? Anyway, there is zero expectation of real-time anything with tracking this kind of analytics data, and it's okay if there's some lag. So the flow of the data through here is the user watches the video, and some request gets sent to the application. The application writes an event to the message store saying, hey, the video was viewed, and at that point, the application renders a response to the user. We can actually see this in action, sort of. Here is an amazing website called Video Tutorials, and this is the homepage, if you couldn't tell. There is no actual video, but I can click this button to simulate the end of watching one. And you'll notice right now it says there has only been one video watched, so I'll just refresh the page just so we can all be convinced about that. And I'm going to click this button, and this is exciting. It's going to send a request to the server saying a video was watched. And then the server is going to respond. It did it! But you'll notice the count still says 1 videos. See, it's even good with the plural words there. So why does it still say 1? Well, because, like I said, the request goes to the server, an event gets written, it's an aggregator's job to update the database that tells me how many videos have been seen, but that didn't happen before I rendered a response to the user. And that's okay, because again, I don't need it in real time. So if I just refresh the page here now, look at that, 2. Incredible. You saw it here first. So sometimes it's okay to just not worry about it. Like Elsa said in the movie Frozen, let it flow, because that's what she did. She was a programmer. And just let the data happen as you want it to. Next one, I like to call this one stalling for time. Who here has ever registered for a website before? Nice. When you registered for a website, did you by chance get taken to a page that said, hey, thanks for registering. We'll send you an email. Go click it to confirm your email address. Yeah, that happens a lot. I like to think that's them just stalling for time, right? I mean, there's reasons to verify an email address, but it provides perfect cover for hiding the fact that when you registered, there isn't yet that formal record of it yet because it's flowing through the event system. So This kind of a strategy could also be used like when you place an order on an e-commerce site, right? You go to a, hey, thanks, we got your order page, and you don't get any more information, but you don't really expect it either, right? They'll tell you if there's a problem or whatnot. Or with bank transfers, those certainly don't happen immediately. So you don't have to show it in real time. So what does that scenario look like? Oh, here's a metaphor for it. This is a swan. Such grace, very bird. They look amazing on top of the water, right? They're just poised and elegant. But if you look under the water, what are their feet doing? It's like they lose some of that grace and elegance, right? This is exactly the stalling for time strategy. So you're in a situation where you need time for background processing. You want to show the user that something is happening. And so, for example, with a user registration, a user will submit their registration, and you want to send an email. So just send them to a static screen. And they're none the wiser because they weren't expecting anything real time. And what happens is they submit the registration, the application renders the go check your email. Some registration service, as part of its flow, will write a command that an email service picks up to send the email. That probably happens in less than a second, more than you want in a request response cycle, but small enough that unless they're like, seriously, like they've opened up your site and Gmail, and as soon as they hit submit, they're over here just spamming the refresh button. They're not going to know the difference. So you get to look like a swan, and your users are happy. So the point to it is, with both of these examples, is when I come from the MVC CRUD world, that is like the hyper optimization for immediate responses. There are cases where I really do need an answer right now, but I don't need that for every use case. And so the MVC CRUD training tells me I have to, every response, I need an answer right now, otherwise there's big problems and people will probably die. But that just isn't the case in a lot of scenarios. So ask the question, what experience do I need to present to the users? What do they expect? And if they don't expect an immediate response, you can not give them one, and that's just fine. So the last one is, as we get closer to needing faster responses. One thing I didn't talk about in the intro is when you're doing an event-based system like this, there's a lot of analysis that has to go up front with that. And I don't mean like waterfall style 9 months of it, but a week or two figuring out what you're actually doing is still agile in my book, right? A week or two is not that long. And if a week or two of planning can save you the kinds of problems that happen when you work with a well-known Ruby framework for building web applications, that time is well spent. So back to the video tutorials example. Suppose you are letting people upload videos because you need videos to show your users. And there are rules around valid names, right? We don't want blank names. We don't want names with bad words in them. But those rules, they live in a service. And services process things asynchronously, so when they submit a name to me, I don't know if it was a good one or not. Now, I could duplicate all of the rules that the service will enforce inside of an application, but if those ever change, now I've got to change it in 2 places. And I think a good solution to this is just embrace the evented model. We don't want to display invalid names to viewers, so like if I'm the content creator and you all are just coming to the site, I don't want to show you the incorrect names or take the video down just because I tried to submit a name that shouldn't have been there. But at the same time, it would be good if I saw the bad name I tried to put in there so that I could fix it. So let's tell a little story here. This is Mr. Grumpy Pants, and he tries to make horrible experiences on websites for people. And using our crude tools, he tries to send some bad words to this video that already has a lovely name. Now, if I'm still thinking in MVC CRUD here, my alarm bells are going off. Like, I have got to stop that. I know that's not what stop signs look like in Europe, but I was so thrilled that Google Slides had an 8-sided figure. So, yay. That's not even what a stop sign looks like in the States either. So anyway, the alarm bells are going off, and I've got to stop this because this row in this database, that is it. That is the entirety of what it means to be a video in my system. And if something bad happens there, I don't even know how to recover from that because I don't have any history. All I have is what it's currently named. But I would contend with the invented model, it's not that big of a deal, right? Why? Okay, so here's the thing that I'm afraid of. The bad name gets through. There's evil laughter from Mr. Grumpy Pants, who's now happy, and children are sad. That one is intentional. That's like when you know something's really serious, is when you have a 1 mixed in with your exclamation points. But what if we were dealing with an evented model, right? So the video's been uploaded. Mr. Grumpy Pants, he sends his request that he wants to have this bad title, and as an application, you're just like, okay, fine, you sent me a name. And he thinks he's so happy because his name got through. And in a sense, it did. We recorded it. The fact that he submitted an invalid name, that's totally a part of that video's history, right? It happened. Can't argue with that. But we have events. We have aggregators, CQRS, like Andre was talking about. I can take these events and shape them into one form for the kiddos, right? They get a nice screen with that video and the lovely name that doesn't offend them and doesn't cause tears. But then Mr. Grumpy Pants, for him, for his view of the video, we get to say, hey, bucko, you've got to fix this thing. So from the same data, we get these different views. These things that normally were database level validations, I can elevate them into my core business model. Right? Why do I push that off? Andre, you mentioned that you got Active Record quickly became a problem point for you. It did for me as well. And one of the things was these validations. Why are those baked into the database layer? Your validations, what is valid data in your system? It's not a persistence concern. That's part of your core domain model. And so by pulling it out of there, I can just have a service control that. And that now is a first-class citizen in my system, allowing me to handle this potentially disastrous situation by showing one thing to the kiddos and one thing to the uploader who sent the bad name. So embrace the event model, let the bad data through, but you don't have to show it to the users. You don't have to act on it. All you're capturing is that, oh yeah, person submitted a bad event. That's fine. Now what am I going to do about it? And the kind of temporal flow through that, of course, is person sends the name, write the command to the message store, immediately render the response. Then in the next step, this is a fun diagram, the publishing service picks up the command, processes it, validates it, writes back the success or not, and the aggregator aggregates that into a materialized view. And this is also a for because those happen at the same time. From the moment that happened, the UI can be polling to see if the command has processed. Because when I write a command, it's true that the whole operation hasn't completed, but I do know the ID of the command that I wrote, so I can tell if it's been processed or not. So, right, even that can be handled properly if your mental model is, first, what do I need to provide my users versus, oh, this just goes in a controller and a model and stuff. So that one doesn't matter anymore. All right, so concluding now. Again, I just want to say I love the microservices architecture. There's not one, right? But the principles of it, the separation of concerns, the separation of write model from read model, it's fantastic. It's fun to work with. And if you're in a distributed system, it's really fun when you write an event and your little electronic minions go doing your will. That's always exciting. But if you bring the MVC CRUD way of thinking to a microservices architecture, it won't make any sense, and you'll get a zebra shape with a human face, and that will disturb you. So start thinking about what it is you want to give to your users before you start coding more. That's good advice in any case, but it's absolutely critical in an architecture like this. Use the event model. It gives you options you didn't have before, like accepting the bad input and dealing with it after the fact. always be working with your business team and your UX people. We've all seen what UIs look like when developers build them. I mean, there are some outliers, right? But I don't think any of you would want to use any UI that I came up with. So always ask yourself the right questions. And honestly, when you're asking the right questions, the technological solutions will reveal themselves. If you want some more info, I recommend reading the Eventide project. It's fantastic reading. Even if you don't use it in your day-to-day work, it will inform a lot of things for you. Like I said, I work in Node.js mostly day-to-day, but it has really helped me understand microservices a lot better. I have a mailing list if you're interested, and the slides are not yet posted there, but they will be for whatever reason using my phone. Google Slides was telling me, sorry, sharing is not available. So I don't know, I'll get that fixed. And I do have code for the stuff that we talked about, and I'll get that posted and share it on Twitter. And then additional resources, good people to follow in this space. Oh my gosh, I left that last one in there. Pretend that isn't there because this is a Ruby conference. And happy coding. Any questions? Yeah.
Hey, when do you count a command as processed? Like when the aggregator has aggregated it or when the service has produced an event?
I would consider it when the service has produced the event, because the service is the thing that's ultimately responsible for processing the command. And so when it does that, it's been processed. There will be, of course, an additional slight delay before aggregators pick that up to signal it to the rest of the world. But that really is the moment that the command is processed. Thanks. The next stop on the journey is, oh yeah, sorry, I was gonna say, so if there are no more questions, I get it.
Hi. I wonder if we validate each piece of data in this way, and we ask our data creator to change it somehow, it looks to me that it increases the complexity of the system tremendously. So we could have not only the label of the video, which should be changed, but the description, etc. So a lot of other fields, and it looks to me a lot of new forms on UI side should be added if we choose this path. How would you handle this complexity?
Yeah, it's a great question. So to be sure, you don't have to go this way. The sort of model that MVC CRUD chooses in every case is still an option in some cases. So I'm not trying to say never do that, but I am saying there are other options. That said, there are other aspects to building a UI for a system like this I didn't talk about, and that's a concept like task-driven user interfaces. So most systems that I've been in, when you go to do something, they just present you a gigantic form that has almost every field that's in a database. And you just go edit all those fields and hit submit. So you have a whole lot of things on there. And one of the drawbacks to that is the process that I'm trying to do is not encoded in the software, right? I have to know that. And if I'm working in an office on this piece of software and I leave the company, sure hope I train someone else that they know that they're supposed to go edit this thing to do part of the process and here to edit it. So when you do this other aspect with a more task-driven interface, there's a really good chance that the forms are going to be smaller in the first place. So when you're not going to submit this massive form with 3 things that need to be fixed. So I think that would help a lot with the complexity. And it is true, I would imagine that on average, if you take that approach, you will have more screens to do. But complexity, I don't from my perspective now, having worked with microservices for so long, I don't find it more complex. It's more typing for sure, but typing is rarely my bottleneck when I'm trying to get stuff done. And putting up a screen isn't that hard to do, right? I can do that okay. But the way that it all flows and executes, I still find that to be more straightforward. Have you ever had one of those piggy banks where you drop a coin in it and the coin rolls down and then hits the slot it's supposed to go in and just falls? To me, that's how an event source system works, right? The events are just flowing and they hit their spots and they do their thing. Whereas with CRUD, I've got to do like all the weird validation stuff. So um, probably more elements because they're smaller, but I'd find that each one has less complexity than the larger ones would have in an MVC CRUD. So more things of less complexity I find easier to work with than fewer things with a lot of complexity. Does that answer your question?
Yeah, sure.
Okay.
Thanks.
Thank you. Sorry, I have a question. What are your strategies or their experience to migrate the materialized data to event store? Usually you don't have an order or the things, the data or time when this events has occurred. So
Yeah, that is a great question. And at my work, that's the big one we're struggling with right now. I work at a commercial real estate company, and let's just say that the systems that have powered that type of business for the past several decades aren't really well. They've been around for a while, let's just say, and different design patterns went into them. So the hard answer is to begin with, like you said, the good domain data, it's already gone. It's like a compression algorithm that loses information. How do you get it back? Well, you can't. It's gone. And so what we do is say we have some big piece of data from this legacy system, and really it's like that original users table. It's a combination, an aggregation of many different domains. I usually just will take that, I build the new model first. What should it look like? And get that working. And then I need to map what exists to what's there. And so I'll have different events. So like legacy foo imported, that will be the start of streams for the new data model. And they're just not as good as it would have been if I had had the domain model from the get-go, but it's the best I've got. And with a separate event type around it, I can distinguish what came from the old system from the new stuff. And yeah, just hope it works. I mean, it will work, but it's challenging because what you need to have good data is already gone. So you're left with just what you have, which, I mean, it is an event that this thing was put into this database. It's not a good business event, but it is an event, and I can still get advantages of the pub sub architecture from it, which is really what I'm after. But yeah, so that's what I usually do in that situation. But thank you so much.